Everyone hear me? All right, we're going to get started. We have a pretty packed session, so I don't want to waste any more time. Hi, everyone. I'm TK. This is Ashwini. We work in the SQL Server BI team, and we're going to talk to you today about what's coming in SQL Server Denali for analysis services and Power Pivot. So before we get started, just a quick show of hands. How many of you are actively using analysis services to build solutions or have solutions deployed in production? Most of you. That's great.
Thank you.
And how many of you have used Power Pivot or have rolled Power Pivot out to your users? A good number of you.
How many have seen Power Pivot already? OK, thank you.
OK. Good. So Power Pivot obviously is a V1 product that we released last year as part of the SQL Server 2008 R2 release. It's a new self-service BI tool. It has a close relationship with Excel 2010 and SharePoint 2010. Analysis services, on the other hand, is a very mature product. The first release went out as part of SQL Server 7.0. It's been through 5 major releases, and SQL Server Denali is going to be the 6th release for analysis services. Both Ash and I have been involved with this product since the very first release, so it's a very successful product. It is the leading OLAP engine out in the market. We have a rich ecosystem of developers, partners, system integrators. Many of you in the audience here belong to this community. There's a lot of client tools that have been built on top of analysis services. And recently, we see analysis services as being used more and more to solve increasingly complex business problems. We see customers using analysis services to unprecedented levels of scale as well as complexity. How many of you attended the previous session on Tier 1 applications using AS? So you kind of get a sense for the kinds of applications that are being built with analysis services. Clearly, it's going beyond the classic norm for traditional BI applications. And so we're very proud of this product today. And when we started looking ahead to SQL Server Denali and beyond, we want to take a step back and say, the current incarnation of analysis services that you have today was something that we conceived at the beginning of the last decade. It's almost a decade old. And we said, where do we want to take this product? So we wanted to come up with a set of key principles and come up with a multi-year vision, a multi-release vision for this product to take it forward. And one of the first principles we said is, we first of all want to make sure we build on top of the strengths and the success of the current product that we have today. We have a very rich ecosystem of tools. We have a rich ecosystem of developers and partners. We want to make sure we carry forward this ecosystem into this new vision. At the same time, we want to extend the reach of analysis services to a broader user base than we have today. If you walk around in tech ed today and you just pick a person at random and ask them about what they know or think about BI, there's a good chance that some of them are going to say, yeah, I've heard about BI. I'm not really sure what that means. Sounds like a fancy term. I'm not really sure I get it. Talk to someone else. They might say, yeah, I've heard of OLAP and multidimensional modeling. Sounds pretty cool and interesting. But no, it also sounds complex. I don't know if I have the time to go learn that stuff, right? On the other hand, if you go and pick a person at random and ask them, what do you think about relational database? Do you know what that is? Say, yeah, even if this person is not a database developer or a DBA, they're going to say, you know what, yeah, I learned about that in college. I kind of get it. So if I had to go build a database and use it for my application, I could kind of see myself doing that. So that's what we mean. We want to extend the reach of BI, Microsoft BI, to the broad set of developers and IT pros in the Microsoft community. And we really feel that in order to be able to do that, we need to go embrace the relational data model and bring it into the fold of Microsoft BI. It's something that is well understood by developers and IT pros. We want to bring that into the fold of analysis services. Analysis services is the foundation of the Microsoft BI stack. It serves as the model that powers all of the end user experiences. We want to make sure we embrace that. At the same time, we want to make sure that we carry forward the existing capabilities in OLAP that we have in the product. So we want to bring together relational and multidimensional modeling under one BI platform so that provides the best of both worlds. And we recognize that Not all BI applications are built equal. They come with varying sets of needs. Sometimes you want to build a BI application quickly with a fast time to solution. And sometimes you want to build a BI application that has advanced needs in terms of scale, performance, complexity, with calculation complexity, modeling complexity. We want to make sure that we recognize all of these needs in this platform and provide the flexibility that helps you build all of these applications. And the BI semantic model is really the name that we give to this vision for analysis services that encompasses all of these principles that we've outlined here. Okay? So what is the BI semantic model? The BI semantic model is essentially one model that serves all of the end-user experiences for Microsoft BI. It's a model that integrates data from a variety of data sources, whether they're traditional data sources such as line of business applications, database systems, or non-traditional sources such as web services, OData feeds, text files, spreadsheets. We want to be able to integrate data from a variety of sources, enrich that data, accelerate the access to that data, and then serve it up using a data model experience that is appropriate for a variety of client tools. Whether the client tool happens to be something that enables end users to do interactive analysis, data visualization, reporting, scorecarding, dashboarding, or whether it's a custom application that is built for the end users, we want to make sure that this model, this platform, lights up those experiences regardless of how the model was built by the data modeler. Not only that, not only is the semantic model something that powers the entire range of client tool experiences, it is also the technology that powers the entire spectrum of BI applications that you can build using the Microsoft BI stack. Whether it's a personal BI application that a business user has built using Power Pivot and Excel for his or her own personal use, whether it's a team BI application that a business user has built and shared with his or her colleagues within a small organization, or whether it's a corporate BI application that was built and sanctioned by IT and rolled out to a large user base. Regardless of where your BI application falls along this spectrum, all the way from personal BI to corporate BI, we want to make sure that this BI semantic model is the one technology that powers all of these BI application building experiences. And that really enables some really powerful scenarios. It enables applications to be able to migrate from one part of the spectrum all the way to the other part of the spectrum and move back and so forth. We will bet on one technology that powers all of this. So without saying a whole lot of more words, I want to hand it over to Ashwini, who can show in terms of the product what we exactly mean by this vision.
Okay, can you hear me in the back? Yeah? Okay, so just warning, this is a build of the product from Saturday. My flight left on Monday morning. So if something goes
we'll have a conversation
exciting
about that later.
So you should be on the edge of your seats. This is something that we, within the last year, TK and I were just talking earlier outside, essentially in May of last year, or June-ish of last year, is when we started development for this version. And what you'll see is just the team has stepped up and delivered a lot of functionality. There's just so much that, in fact, we have many sessions throughout the conference. This is one, just to give you a taste of what the capabilities are. Then there's a session that Casper and I are doing on DAX on Thursday. There's another session that is Julie here? Not yet. There's another, one of our colleagues, Julie, who's actually going deeper into the experience, the UI that you'll see. She's doing a session tomorrow. And we also show Crescent. How many folks have seen Crescent already? Okay, great. There are 2 sessions on Crescent later today also. So just a lot of content, there's a lot of value coming at you. And as is the case with a lot of value, sometimes you get surprises. So if you get surprises during the session, I'll have to redo it. Okay, so let's take a look at how do you connect to BI semantic model. So I'm in Excel. I'll show Excel connecting to a BISM and also show Crescent going against the same model itself. Okay? In this case, this is a semantic model that was created by IT. So it's running on a standalone server. And as in any other analysis services database, all I need to do is to say, what's my server name? And there are two databases on there. I see perspectives, I see cubes. I can connect to this cube. Yep. Okay. And on the right, I see a multidimensional view of the model. So I see measure groups, I see measures, I see KPIs. And I can go ahead and do what all of you are quite familiar with. Let's do by subcategory. Let's look at the total sales. Right? It's fairly straightforward analysis. And I've just connected to a model that's running on the server. Right? Now I'm going to start crescent up and going against the same model. Right? What's crucial here is to say I'm not doing any translation. There's no separate store. There's no separate place I need to manage security. It is that same model that I'll be using for crescent reporting as well. So over here, I've already launched Crescent. By the way, in Denali, in this version of SQL Server, one of the things we are introducing is within SharePoint, you'll have types of files that are pointers to databases that are running on standalone servers. Right? So it's just a connection information to a database running on server. And it gives you capabilities such as creating a Crescent report from it or launching Excel connected to it. Right? So
basically,
again,
it's a moniker to a semantic model that's running on an SSAS server. And once you have this file uploaded to SharePoint, then a business user can just go click on it and say, what can I do with this model? Well, you can launch Crescent, you can launch Excel, you can launch Performance Point, you can do all sorts of things with this model.
Right, so I've already launched Crescent here. And what you'll notice on the right is a more tabular view of the model. So I don't see dimensions and measure groups anymore. I see tables and columns within those tables. And I can still do reporting against it. So say a similar report is what I did, a similar view is what I did before, total sales. And of course, Crescent is a beautiful experience. I'm not going to do justice to the Crescent experience. But the key point here is that I'm using two tools against the same model. Okay? So far, we've connected against a database that's created and managed by IT. It's on a standalone server. Now, as TK mentioned, any Power Pivot workbook also has within it embedded a BI semantic model. Right? All the existing, including the 2008 R2, any Power Pivot workbooks created today have the BI semantic model already in them. So let's switch to, this is a Power Pivot workbook I've uploaded to SharePoint. And in Excel, let's go back to Excel. I'm going to connect to that database. Data from analysis services. And let me just go over to my cheat sheet, copy the URL.
We're using the word database and model kind of interchangeably in the classic analysis services sense. We use the database as a container for models, but I mean, bear with us while we kind of use those words interchangeably.
Okay, so you noticed last time I included the server name here. Now what I'm going to do is just include the URL to the workbook. Right? So it is HTTP, blah, blah, blah. And it's within my Power Pivot gallery, I've got an Excel workbook. And that's the only change that I had to do from a client perspective. Okay? I go through. And now I see the metadata within. I see the model that is embedded within that workbook. And I can see there is a notion of perspective within that embedded model. There's a notion of cubes also. I can connect to the cube. Yeah, fine. And again, what you'll see on the right is a view identical to the one that you saw connecting to analysis services standalone. Again, you see measures, you see measure groups, you see dimensions, you see KPIs. Right? If I scroll down here, you'll see hierarchies. Right? So employee has a parent-child hierarchy. Or on the product table, I've got a user-defined hierarchy there. All of this was created as a side effect of working inside Power Pivot. So as users were doing operations, as they were bringing in data, as they were defining calculations, as they were defining measures, the model, the BI semantic model that's embedded within Power Pivot was enriched, right? Now, same thing I can do with Crescent again. I can have Crescent, it'll look pretty boring actually, but I can have, it's not very exciting from a visual perspective because it's not very different. On the Power Pivot gallery itself, I can say launch a Crescent report. And again, Crescent is now connecting to the database that's embedded within Power Pivot, and I see the tabular view against it, right? So this is, as TK was mentioning, it is that one experience that goes from, hang on, I'm not done yet.
Oh, you're not. Sorry.
Am I done? Import from Power Pivot. So what we saw was standalone server, Excel Crescent, Power Pivot, Excel Crescent. Now, one of the other features that we have is import from Power Pivot. So if you have Power Pivot workbooks that are being used and you want IT to take full control over it and management over it, you can seamlessly take that Power Pivot workbook, extract the BI semantic model, and hydrate it, load it on a server that's running standalone. Right? So it is the same model, the same technology that's used for both self-service and for corporate BI applications. Okay, any questions so far? This is the key point.
So when you do the import to, I would think it's a standalone analysis services.
Mm-hmm.
Is this functionality only going to be in Denali? It's not on,
The question is the capability of importing a Power Pivot workbook into analysis services available only in Denali? Yes. The answer is yes.
Yeah, we'll take a look at actually how do you build one of these models later on in the second demo. Thank you.
The ability to connect up to that Excel workbook, is that only available if SharePoint is working in classic Windows authentication?
So the question is the ability to connect to a workbook that's stored in SharePoint, is that require Windows authentication?
Yes, yes, that's right.
I believe the answer is yes right now. So let's keep going. So before we dive more into details about what exactly the BI semantic model is, it kind of looks, we've provided a very high-level conceptual overview, and I want to spend some more time diving into the details. Before we do that, just quick point to address, what happens to existing analysis services applications that have been built using SQL Server 2005, 2008, or R2? And the answer is very simple, actually. When you upgrade your analysis services server or your projects, your Visual Studio projects to Denali, every existing analysis services cube or UDM just becomes a BI semantic model. This isn't like some sort of upgrade process or migration process or anything like that. Every UDM just becomes a BI semantic model. The reason for that is the BI semantic model encompasses all of the capabilities of what the UDM offers today and a lot more. It offers all of the existing modeling experiences that the UDM offers. It offers all of the existing interfaces that the UDM offers, and it offers a bunch of other modeling experiences and a bunch of new interfaces. So it essentially encompasses the capabilities of the UDM as such. So in that sense, the word UDM in some ways is going to be used less in the context of Denali, because the BI semantic the D in the word UDM is dimensional. And the BI semantic model is really an evolution of what the UDM was. It's a hybrid model. It supports both tabular and dimensional modeling, both for the model developer as well as the model consumer. So it's a hybrid model that encompasses all of the capabilities. So if you're building a new application using Denali, you will have access to all of the capabilities that the UDM had. You could go about doing things the way you've already done and still benefit from the new platform. Or you can take advantage of all of the new capabilities, the new features in the model, and that we'll talk about in a moment. Okay?
So existing apps, Excel was as Excel was shipping, right? In my demo, it was just the shipping Excel. There are no changes required to your application to connect to BI semantic model, because any UDM automatically is a BI semantic model in Denali.
So when we talked about the key principles of the vision for the product, we were very clear that we want to carry forward the existing ecosystem of client tools and applications forward, and that's what we do with the BI semantic model. Since we're not taking away any of the existing capabilities in the model or in the interfaces, all of the existing tools Microsoft tools like Excel, Performance Point, reporting services, they get carried forward. All of the third-party tools, there's a rich ecosystem of third-party tools built on top of AS today, and they just get carried forward. So let's look a little bit deeper into the BI semantic model conceptual architecture. At the bottom, you've got data sources. The model consumes data sources consumes data from a variety of data sources. All of the traditional relational databases, SQL Server, Oracle, Teradata, you name it, they're all supported. Line of business applications, you can pull data out of line of business applications. You can pull in data from spreadsheets and text files lying around. OData feeds, you can pull in data from Netflix or Facebook. Any public service that exposes its data via OData, you can pull that data into the model. Cloud services such as SQL Azure are also supported. And the BI semantic model then enriches and accelerates the data and provides a model that gets exposed to all of the tools in the Microsoft BI stack, whether it's reporting services, including Project Crescent, Excel, SharePoint scorecards and dashboards, third-party applications, even Power Pivot. This one is a little interesting to kind of comprehend at first. On one hand, we said every Power Pivot workbook itself has a little BI semantic model within it. The end user, the business user is building Power Pivot application, doesn't really know or care about the model. He's just doing his job, and a model gets generated behind the scenes. Well, that model can also be sourced from a BI semantic model. So this is kind of where IT has published a corporate BI solution with a model on an AS server, and a business user then takes a portion of that and then goes matches it up with other data sources. That's an interesting scenario that's possible as well. Now, the model can be thought of conceptually in terms of three layers: the data model, the business logic and query layer, and the data access layer. The data model is the model that that both the model designer, the developer who builds the model, as well as the model consumer, which is the client tool and the end user consuming the model. This is the model that they use, they experience. And obviously, the model developer uses Visual Studio and bids to develop the model, and the client tool uses the interfaces exposed by the model. As far as business logic and queries are concerned, the BI semantic model offers both MDX as well as DAX. MDX is a very well-known calculation and query language pioneered by analysis services since the very first release. DAX is a new expression language, now evolving into a query language as well, that was introduced as part of Power Pivot. DAX is an expression language based on Excel formulas. It's built on top of tabular concepts, just tables and relationships. So it really lowers the barrier to entry in terms of building sophisticated business logic into your models. And we have a whole session dedicated to DAX that Ashwini and Casper are doing on Thursday. And in terms of data access, the model offers you the option to either cache the data or have it pass through to the underlying data source. Now, in Denali, you're already familiar with MOLAP and ROLAP. In Denali, we're offering Vertipack as a new option for caching the data in the model. Vertipack is a brand new in-memory column store engine. It caches all of the data in memory, organizes it by column, and uses state-of-the-art compression techniques to compress the data, manage it in memory, and then operate on it in a compressed state. And it produces blazing fast performance to BI-type queries. Vertipack does not require any indexing or aggregations. It just does brute force scanning of data in memory. And we'll look at that in a little bit. It turns out that Vertipack is the same column store engine that powers Power Pivot for Excel, Power Pivot for SharePoint, analysis services, as well as the column store index in SQL Server. I don't know how many of you saw Quentin's session yesterday where they showed the column store index in SQL Server. Well, it's the same Vertipack technology that's powering that column store index as well. And then we have direct query, which is a new clean pass-through mode to a backend data source that we're introducing in Denali as well, and we'll get to that in a moment. Now, to elaborate on the hybrid nature of the model, I just want to take a few scenarios and go through them. So let's take this example where there is a sales model that has been developed by a BI professional. I'm calling him the model developer. And that little ellipsoid is the symbol for the Visual Studio 2010. So you will see in a moment all of the bids projects for analysis services, reporting services, integration services now run inside the Visual Studio 2010 shell. So the model developer has used Visual Studio to build a BI semantic model using the tabular experience. The model developer has enriched the model using DAX calculations, and the model happens to be cached in the Vertipack column store. This happens to be this model that I'm calling the sales model. And let's say an end user then connects to this model using Crescent. Crescent, being an ad hoc reporting tool, consumes the model using the tabular interface, and it sends DAX queries to the model. So that's the picture you see of a specific use case of the model developer building a model and consumed via Crescent. Now, the exact same model can be consumed via Excel. This is something that Ashwini showed. And in this scenario, the model developer still, nothing changed in terms of what the model developer did. On the other hand, the end user is now seeing a multidimensional view of the model. Excel is consuming the model as if it were a cube, essentially, as if it were a multidimensional model. And it sends MDX queries to the model. Now you can see the hybrid nature of the model starting to show up, right? And it's still using the Vertipack storage engine underneath the covers. Another example, let's say the model developer has used the classic multidimensional modeling experience, something that you're all familiar with prior versions of analysis services. And he's used MDX scripts to enrich the model with calculated members, scopes, and assignments, and so forth. And the data happens to be cached in the MOLAP engine. And of course, Excel users point to it, and they consume a multidimensional view of the model and send MDX queries. And now the same model can then be consumed by an end user using Crescent as well. So even though the model developer has built it using the multidimensional experience, Crescent can then consume it using the tabular modeling interface and send DAX queries. The point we're trying to make here, it's a truly hybrid model. The model developer chooses to build it the way that works best for them, and the model consumer or the client tool chooses to consume it in the way that works best for the consumption experience. Now, I just want to call out in the upcoming CTP or community technology preview that was announced to come out later this summer, this particular experience will not light up. It's something that we're still working on. It will come sometime after the CDP. So without further ado, I want to hand it over to Ashwini, and we'll do kind of a whirlwind tour of everything that's coming in Denali. At a very high level, the idea is to give you a sense for all of these technologies that are showing up in Denali, and then you'll have deep dive sessions over the next couple of days that focus on these in detail.
Yeah, you might have questions about what is a tabular experience or multidimensional. We'll go over that. So hold off on the questions for now, and we'll get to the questions in case it's a little confusing. The slides were a little confusing. OK, so Visual Studio 2010. This is something that a lot of customers asked us for having an upgraded shell. With Denali, inside Visual Studio 2010, you'll get all the BI projects, analysis services, integration services, reporting services, as well as the database projects inside Project Juno. The shell would be called Project Juno.
So Juno is just the code name for the enhanced SQL Server developer experience, which encapsulates all of the BI projects and the database project.
Right. So as you're used to, how many people use BIDS today? OK, most of you. So you're very used to this shell. You're used to the concept of having multiple types of projects within a solution. You're used to having the whole properties window and this check-in, check-out, the source control, et cetera. So I won't go over that. You're also used to creating a new project. And here is, let me just call out a few differences. So this is the different types of projects, IS, RS, and AS. For AS, now you see two different types of projects. There's an AS multidimensional project, which is what you have today, the cube designers. And you also have the tabular project, which is new in Denali. The other thing I want to show is there was a question about importing from Power Pivot. This is that option for saying, I want to create a new project. And the source, the starting point for that project should be a Power Pivot workbook, right? So that you just start off here.
Actually, it's not the source. It's really a starting point. It literally takes the contents of the model inside the Power Pivot workbook and hydrates a a starter Visual Studio project from that.
That's true. Okay, so this is the multidimensional project. This is what you're used to. I see cubes, I see dimensions, I see measure groups. And let's switch now to the tabular project. I've created one already here. And this is very similar to what you see in Power Pivot, right? It's very tabular in nature. It's relational. One of the things that TK mentioned was the fact that for the previous designer, I think both he and I and Julie and a lot of people have had over the last decade many sessions in different conferences where we're introducing things such as dimensions and measure groups and how do you create a DSV and just a lot of information that you had to learn to be able to create your first analysis services cube, which is, just requires a lot of learning curve. Whereas here, tabular model, if you're an Excel user, if you are familiar with relational databases, you can immediately connect to your data source and load data, right? This is the view that you get. It's very data-centric. So you see all your data. You can, let's take a look at the diagram. You can see the diagram view as well, and you can see how different tables are created together. Now, one of the differences between, I just want to call out, is you also have a DSV within the cubes, within the multidimensional project. And this is your view of your data source. These are all the tables that exist in your data source, and then you build a cube on top of it. Whereas here, what you're seeing in the tabular designer, this is your model. Your model is tabular, right? So all these tables that you have here is not just from your data source, they can also be exposed directly to your end users through your client applications. Now,
one thing that you see in the tabular modeling experience, it's something, it was designed from the get-go to sort of make the act of building a model extremely straightforward. If you just point to a data source and pull in a bunch of tables and they have predefined relationships between them, you've already got a model. You can just go deploy it and just start building Crescent reports on top of it. There's no additional work required. You can optionally then go and enrich the model, cache the model, do all sorts of other things on top of it.
Yeah, let's take a look at enriching some of the models. So I'll go back to the table view. And I've got a table here called customer. These are all the columns that I got from my data source. Now, there are a few columns. Now, since this is the view that we are exposing out to the client applications, if I hide a column here, it's hidden from the view that customers see, right? So this is an example of a column I've hidden. This is an example of a column that I've created using calculations. So if I zoom in on the calculation, it's a very simple calc that I've got, which is just concatenating first name, space, and last name, right? So I'm now enriching the model that I got from my data source. There are some other calculations. So this is a customer table. I want to find out when was the first time customer bought anything from me. And excuse me, while I zoom in again. So this is a DAX function, which essentially says first non-blank. It's a BI concept, but it's created, one of the things that Casper and I will do on Thursday is to go over the surface area of DAX and see how much of it is targeted at rich BI applications. And I can go in and continue to build other examples such as this one, which is when has this person been a customer since? Right? Since when has this customer been with us? Basically says if I don't have a date purchased, then it's been a customer since 2000. Otherwise, whatever the year was of the first purchase, that's the year. It's like on my credit card, I see customer since or member since 94. That's what this calculation is doing, right? So I've now extended the model that I've got here. And there are other extensions also. I won't go over all of them. Julie will do that in her session tomorrow, is that, Julie? Yeah? Okay, but one of the things I want to just quickly highlight is, so this is my product table. And, excuse me, on the product, I don't have anything interesting. On the, do I? I do have something interesting on product, which is I've built a hierarchy here. Julie will actually show how do you build a hierarchy, but there's a user hierarchy that as a modeler I've defined here, etc. I can also go through and take a look at different perspectives that I've defined here. Again, Julie will go a lot in details. But essentially what you end up with is this model that while I'm using a tabular experience for building it, if I launch Excel against this model, you see the multidimensional view, right? So this is one of the scenarios that TK had, which is you're building tabular going all the way down and then coming up using multidimensional. And Excel shows you the multidimensional views on the side. So you see dimensions, measure groups, KPIs, and all. And it's sending MDX queries to the same model that you're building using tabular experience, right? Okay, so next up. One of the things I want to highlight is all the work that you've seen so far here is also available in Power Pivot. So in Power Pivot in Denali, it allows you to create such rich calculations, allows you to have a diagram. So let's just go to, this is a Power Pivot workbook. Let me launch Power Pivot. And here you see the diagram view inside Power Pivot now, right? And all the work, all the hierarchy building, all the KPIs, all that is available also within Power Pivot. So that'll be a new additions to functionality that we provided. But go back to Visual Studio.
And again, the point there to be made is Power Pivot is application building experience for business users. Analysis services targets professionals. But at the same time, it's the same model that powers both, and there is no reason why we feel that we should artificially constrain what business users should do or professionals should do. There are certain features that make sense only for IT pros or developers to be able to do, things that target high-end scale. I mean, a Power Pivot workbook is limited to 2 gigabytes, and even that's a bit of a stretch for a business user to go build and manage. So in terms of size and scale, those are areas that we will limit the capabilities of applications built by business users. But in terms of the modeling surface area, there isn't something artificial that we want to impose on top of the business users. If you think about Excel, it's a very much learn-as-you-go tool. You can start with Excel and just build simple lists of things, and then you start learning Excel and growing your skills in Excel. You can start building some pretty powerful applications using it. The same thing is what we want to offer with Power Pivot.
Right, so let's take a look at a few of those examples of features that are only in the Visual Studio experience, only in the standalone server. One of the things is the notion of fine-grained security. So we are introducing in Denali, the notion of right now in Power Pivot workbooks are still secured at the whole document level. But if you have a standalone server where you have different users connecting, maybe you have people from Europe connecting, maybe you have people from US connecting, they should only see data for Europe or for US. Or maybe you want to have some set of people be able to read the data set, whereas some other different set of users should be able to process it, or you want to have full admin privileges to other sets of users. So very fine-grained security is necessary if you're building a model that will be used for corporate BI applications, and that will be provided. Another thing that TK mentioned is scale. So if you are building large systems that are not constrained by the Excel limit, you need partitioning, right? You're not going to reload the whole 2 billion rows of data every night. And for that, of course, we will introduce partitions as well. It's not on this table. Any table now you can partition, by the way. So one of the things that for a long time we were getting requests about partitions for dimensions in the multidimensional world. Here, everything is a table, and any table can have partitions within it. So even if you have a dimension table, you can have partitions within it also. In this case, I have not created partitions for the dimension table, but for my sales table, I do have some partitions. And I've got 2001, 2002, through 2004 for each year. I've got a partition defined. And I can either do a WYSIWYG filtering, or I can just change the query also for what defines what that partition is. Once you've defined these partitions, then you can process them independently, as you're used to in analysis services today, right? Now, one of the, around scale, one of the things that we want to highlight is all of this is using Vertipack engine, and it reduces the need for tuning. As TK mentioned, there's no aggregations, there are no indexes that are created. It's just load up and uses the system's horsepower to just do brute scans as quickly, as efficiently as possible. And for that, I have a machine back in Redmond that shows us. which is, some of you may have seen this demo already, but I think it underscores what performance characteristics VertiPack has that gives us the headroom that you can use this for a lot of applications. Here I've got a similar tabular experience within Visual Studio. It's running on a standalone server, so it's not constrained by the memory for Excel. And I've got this table that has 2 billion rows of data within the server, right? And the experience of 2 billion, some of you may have seen this before, is as if I'm working with a few thousand rows. I'm scrolling. I'm at 832 million. I'm scrolling through 2 billion rows of data. And I'm now doing, let's do sort of this 2 billion. Right, so I've just sorted largest to smallest. Let's do filtering of 2 billion down to Europe. And it's all immediate because this is the raw capability of the machine and the software that we're using. These compression algorithms and these scanning algorithms that we're using. It's just so far beyond what we're used to with the technologies today that it just enables this kind of
VertiPack, it exploits not just all of the memory that you have in the machine, it exploits all of the cores. It's an inherently multi-threaded system, so it will dynamically scale to use all of the cores in the machine and will max them out, believe me.
Yeah. And it also scales, the beauty of VertiPack, well, I love VertiPack, the beauty of it is it scales down to running within Excel. So you get still the same experience over 100,000 rows or 10 rows. And it scales up to 2 billion rows. The same technology is scaling all the way up and down. It's not just transactional, it's also, if I'm querying it, here I've got a view. This is slices using the slicer feature. Sorry? There's a question?
Yeah, if you were to have this VertiPack engine, at what point would you find performance difficult to realize out of like a tabular project versus a multi-dimensional project?
Okay, the question is, there are two parts of your question. One is, what is the headroom of VertiPack? And when do you use when do you use the tabular VertiPack versus multidimensional? I'll answer the first one now. The second one, TK will give you much more context. The first one is, the design point for VertiPack is still that data should fit primarily into memory. Right? If it pages to disk, okay, fine, we'll page to disk. But it's designed for your hot data, whatever you're using, the compressed form for that. And I use an order of, a rule of thumb, an order of magnitude less, right? So assume 10x compression over your database, your raw data size. That should fit into memory. And that's what gives you that predictable performance, because as I mentioned, there are no aggregations here. So it just assumes you should be able to scan it through. Now, trade-off between VertiPack and multidimensional, we'll talk about.
Hold that thought, yeah.
Okay, so here, I'm now analyzing that 2 billion rows. So I've got sales for this blank rating for about 600 million rows for that. And I'm just merely clicking along. Every click is sending 10 queries, 10 MDX queries to the server, and each of them send multiple Vertiscan queries down to the Vertiscan engine. And you see how interactive this system is, again, because of the headroom that VertiPack allows you to do. Right?
How much memory is in that server?
Okay, so the question is, how much memory is on that server? Let's take a look. I don't remember, to be honest. This one is running 24 gigs. This is about 9 gigs of data is what we've got for this. Now, it depends on, of course, on your data volumes. We can talk later about what are the different characteristics of VertiPack compression. But a rule of thumb is about 10x compression is what we see. Okay, so that is 2 billion. Okay, so the next up is, I want to go to Profiler just to reinforce a few of the other points that we've talked about. And this is Profiler. VertiPack. So you see here, we've introduced new trace events. There are a lot more trace events that we've added. There's some for locking also. How many people run into problems with query performance when you're doing processing? You get lock timeout errors sometimes, a few of you. This is, as you scale up your deployments, as you have large systems that are doing concurrent queries and processing, sometimes you get these queries that were running fine yesterday, but now are slow. And why are they slow? Well, a lot of the common reasons why they get slow is because of lock contention between processing and queries. And we've added a lot more trace events for locking also. So lock acquired, lock released, how long was a lock held for, lock waiting, what is a lock waiting for. And you can see that for each query and for processing, what are the lock activities that are happening. I won't actually show them, I just want to describe what they are. What I'm showing here are the VertiPack, query events. So here I see, let's scroll to the top. Here I see, as I was using the system for doing the demos, what you saw is I was in Excel, I was using the model in Excel, and Excel was sending MDX queries to the model. And here you see this is what the MDX query looked like. Each MDX query then went down to the in-memory engine to VertiPack, and in this case it sent 2 queries to VertiPack. You also saw me within Crescent, and Crescent is now sending DAX queries. Right? So again, the same model looks nothing like MDX. This is more for those familiar with DAX. There are expressions in DAX that return tables, and we just wrapped around a syntax of evaluating an expression and returning that back as a row set. Right? Again, DAX queries also end up. Let's go. Where was it? DAX query also ended up being sent down to VertiPack, the in-memory engine. So whether MDX or DAX, all of them went down to the VertiPack engine. Now there's one other scenario here which I want to show, which is I've got another Crescent report here. And just like we did for the first one, I'm going to go through and say, give me the product subcategory, and go through here. Sales and sales amount. Right, just exactly what we saw before. If I switch back to Profiler, what you'll see here is something interesting, which is these are the DAX queries. This is the first click that I did. This is the second click that I did. Each of those ended up sending 1 DAX query. But what do you notice? Can somebody point out what is the difference here between this DAX query and the previous ones? And in fact, Daniel in the back has a shirt for anybody that can answer this question.
If you don't have, you got to take out your shirt.
Do you have a shirt, Daniel? So can somebody just look at, there are these like those kids.
Add columns
Huh?
rather than reprocessing everything. It seems like it's tacking on the next piece.
Okay, good observation. I don't know, that wasn't the answer I was looking for. It is true, though. It is right. So maybe, how many shirts do we have? Huh? 8 shirts? So can we give one to this gentleman? Can you just raise your hand so you know?
So quick hint for people. What do you see between the query begin and the query end events?
Hey, the guy in the green shirt. Daniel, the guy in the green shirt.
The green shirt.
What the person said is, it's not calling VertiPack, right? So what you see, which is exactly right, you saw previously query begin, VertiPack, 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 query end. Query begin, query end, no VertiPack. Query begin, query end, no VertiPack, right? And the reason this is, as far as the client is concerned, it's only sending the DAX queries. So the model is concerned, this model is configured not to use VertiPack, but to use direct query, right? Which is, instead of using a cache of your system, again, a lot of customers have told us, hey, with building a cache, you ended up replicating all the data over. I have to redefine all my security up at the cache level. What direct query allows us to do is, if I switch back over to another profiler I've been running on SQL Server, what you see is queries that were being sent by the BI semantic model to your underlying data source. And these are not, you may be used to in the roll app world that we send very low-level queries. These are fairly substantial queries that push all the processing down to your underlying data source, right? So it's not just using your data source as a row store. It's just pushing all that processing down. In case you had other indexes created under your data source, it would use all that intelligence as well, right? So this is direct query in action as well.
So if your scenario is basically if you've got a powerful data warehouse, maybe you've got a SQL Server database with the column store index turned on in SQL Server, Or maybe you have a data warehouse appliance, like a Teradata system or whatnot. Eventually, you'll be able to take a model and then throw it on top of a database such as that and say, I want the model to be lightweight, and then expose the model to my end users, and without having to do a lot of heavyweight caching and lifting on the analysis services side.
Okay, great. So that is direct query. Now let's take a look at the management experience over this. So switch to Management Studio.
What are we doing on time? Yeah, we are on 25 minutes, probably around 10, 15 minutes.
Okay. So I've got, on the top, I've got a multidimensional database. So I've got cubes, I've got dimensions. Within the cubes, I've got measure groups, and so on. And I've got another model that was created using the tabular interface. And here I see tables. Right? I see tables, still see rows, and I can do operations such as processing a table. So Management Studio then gives you a customized, because if you built the project using tables, a customer table, you don't want to, to understand, customer table maps to a customer dimension and a customer measure group. You just see a customer table here as well, and you can operate on the partitions of that customer table.
So we wanted to keep the experience for professionals working with analysis services consistent, even though we wanted to provide flexibility between the professionals and the end users. So if a pro has built the model, he'd like to manage it using the similar experience. But that's not necessarily the same limitation that we impose on top of the end users.
Okay. So one of the other feedbacks that we've got, how many people are familiar with PowerShell? Use PowerShell? Oh, many, okay. And this is something that we were hearing a lot over the last year is PowerShell is, for those not familiar, it is a, let's take a look at the PowerShell. It is a command line, black and white experience over your managing systems. It's very efficient, allows you to write a lot of scripts. And SQL Server has a PowerShell extension already that comes out of the box. In Denali, we're now extending that to also include analysis services. So if I take a look at PowerShell, what you see here is SQL Server databases, integration services, analysis services. Analysis services just shows up as another service within PowerShell. Now, the way PowerShell works is it mounts different services as virtual directories. So I can say, go cd into SQL AS. Now, I can connect to analysis services using either HTTP access or TCP access. So I'm just going to use TCP. And I've got 4 instances that are running on my server. So I'm going to go into the multidimensional now. Right? Now I see databases. So each object in the nodes that essentially that you see in Management Studio ends up being a folder that you can now navigate to inside PowerShell. I can say databases, give me the list of databases. I have one database there, right? So I can just go in. What I want to get to is my cube. So there's analysis. Now let's get to the partition, measure groups. Right, so I've got 2 measure groups here. Let's go to the first. And partitions. Right, so I've got one partition. I see some properties of it. Now I'm going to cheat and essentially use this, which is
have some pretty long command prompts
yeah.
in PowerShell with the analysis services hierarchy.
What I've got here is saying I'm defining a variable which is partitions, and I'm saying there is a partition called fact internet sales, and use that as a variable. And now I can say process this partition.
So this is the beauty of PowerShell. PowerShell is an object-oriented shell. Unlike traditional shells in the Unix world, it might be used to just work with text. PowerShell works with .NET objects. So while you're navigating the hierarchy, you're essentially navigating the AMO object hierarchy. And then when you reach an object, you can invoke methods on the object. So It's very cool.
Yeah, so I'm going to process it. And process type is going to be process full. Right, for those familiar with AMO, this is exactly, this is a shell around AMO. Right? And I'm going to say verbose. And it's processing the partition now. And it's processed the partition, right? And there are other commands also that we provide. These are all the list of commands. You can add roles, you can add members to roles, you can remove members from roles, you can back up databases, you can merge partitions, or you can just send in an XMLA command directly to the server also, right? So fairly rich scripts can be created using PowerShell, just more efficient way for you to do management.
So, and this is a good example of when we say we're bringing both the modeling experiences under a single platform. So for a lot of the shared investments that we do, it accrues to both the modeling experiences. It doesn't matter when they want to build a model using a multidimensional experience or a tabular experience. These sorts of investments you can just leverage regardless of how you go about doing things.
Yeah, there are a lot more that I unfortunately don't have time to go over. There are over, I think last month I checked, there are about 300 improvements in analysis services as you're used to today. This is not counting the new features. It's just reliability, performance, scale fixes that we've done to analysis services today. There are things such as 4 GB string store limit. Right? A lot of people were running into that when you
How
build.
many of you have run into that? The limitation of 4 gigs. Somebody up back there. So yeah, this is a limitation that we've heard repeatedly from customers building the large-scale analysis services solutions, where you run into a limit in terms of the amount of strings storage per attribute that you can have, and that's something that we have eliminated in this release, so you can start to build larger dimensions.
Yeah, another one that we heard was the trace events are, the overhead of trace events is too high. SQL Server has a very low overhead tracing infrastructure called X events, and that's what we're introducing here as well. So that you can, if you wanted to log events such as for auditing purposes, you can have X event started and that'll log information with very low overhead as well. I think that's about it, yeah.
All right, so that was a very quick sort of whirlwind tour of everything in analysis services. Like Ashwini said, we can't do justice in half an hour through all of the surface area, but I encourage you to go to some of the other sessions that we talked about. So this is just a quick summary of everything we showed in this demo. There's definitely more stuff that we can show. I won't go through it. If I were to just kind of summarize at a high level what the BI semantic model vision is about, it's about flexibility, richness, and scale. It's about providing flexibility to BI application developers to do the right thing depending on the needs of their application. It offers a lot of flexibility in terms of the experience that you use to build the model, the interface that client applications can consume. It offers flexibility in terms of the choice of client tools that your end users can use. And it offers a lot of flexibility in terms of how you manage the data, whether you want to cache the data, you want to pass through the queries to the backend data source, whether you want to use MDX or DAX. It's a rich model. It has some pretty advanced modeling constructs in it. It has sophisticated calculation languages such as MDX and DAX, fine-grained security, lots of richness in the model, and you've seen the performance and scale with VertiPack and MoLab. With VertiPack, you get blazing fast performance with very minimal tuning. And on the other hand, MoLab can really scale to the very largest of workloads into the multiple terabytes. So some of you are thinking, all this flexibility is great, but when I go about building a model, how should I build it? I mean, how do I choose what experience is right for me, what technologies are right for me? And this is a topic that's something that we will dive in deeper over the next coming months, provide detailed guidance, provide white papers, and so forth. So this is just a very quick attempt to give you a sense for how you should go thinking about this. And really, it's just like I introduced the BI semantic model in terms of the 3 layers. Think in terms of those 3 layers. What are your needs? What are the needs for your applications along each of those 3 layers of the model? Now, and I'll get to that in a moment, but in the Denali release, we have, like Ashwini showed, 2 projects, 2 experiences for building model. This is for model developers. Many of you in the audience are model developers. And you have a multidimensional project experience and a tabular project experience. The multidimensional project, like today, allows you to use MDX scripts with the MoLab and RollApp storage options. And the tabular experience lets you use DAX with the VertiPack and direct query options. Now, these are just 2 options that we happen to introduce in Denali. Of course, the first one already exists. We introduced the second option. And the guiding principle there was customers are doing a great job today with the multidimensional experience. We wanted to reduce the barrier to entry for analysis services by providing the ability to create solutions really quickly and get going. And that's what the tabular project experience was designed. That was the design principle for that. Now, there's nothing in the model that actually limits us in terms of these restrictions. We've certainly had conversations with customers where they say, you know what, I have this large MOLAP cube, and I could really use that Vertipaq engine and stop doing all of that aggregation designing that I'm having to do today. And so that's something that we could certainly introduce in a future release. If you've built a model using the tabular experience and then you run into maybe certain restrictions that DAX has, and maybe you want to use MDX scripts, calculated members, or scopes and assignments to enrich the model. That's again something that we could certainly consider adding to the modeling experiences. The point I'm trying to make is that there is the model, and then there's the Visual Studio projects or the experiences that you use to build the model. What we have in Denali is a first step in terms of realizing the BI semantic model vision, and it can and will certainly evolve through the releases. Regardless of how the model building experience evolves, the client tools need not care. The client tools still connect to the model using the set of interfaces they're already used to, and they do not have to worry about how the model was actually created. Okay? So that said, let me go back to the topic of this slide, which is how should I build the model? Let's look at very quickly, we don't have a lot of time, but layer by layer, what are the design considerations that you should have? So first of all, looking at the data model. Now I'm looking at it from the model developer lens. I'm not looking at it from the client application lens. Most of the people in this audience, I would guess, are building models, not really consuming it. You're not really building clients. Some of you definitely build custom applications that consume the model, but my focus is mostly on the model developer. The tabular modeling experience, like we've said, it's a familiar model. Most people get the relational data modeling experience. There's a faster time to solution associated with it. For multidimensional, there is a higher upfront learning curve. The tabular model, on the other hand, is pretty simple. Advanced concepts, such as many-to-many relationships, reference relationships, parent-child, those are not concepts that are natively baked into the model. The model certainly lets you do that using calculations and other metaphors, but it's not baked into the model. Multidimensional, on the other hand, some of these advanced modeling concepts are baked into the model. So once your understanding of the model grows, you can start taking advantage of those modeling constructs. The tabular experience is super simple. If you wanted to just wrap a model on top of an already existing data warehouse or a data mart and surface it to your end users, maybe all you want to do is clean up the column names, hide a few columns, do a little bit of joins, and you want to expose it to your end users. The tabular model is just brain dead simple for that sort of experience. The multidimensional model excels at the classic OLAP applications, planning, budgeting, forecasting. There are lots of applications that really need the power of the multidimensional model, the power of MDX scripting, and so forth. And so these are two ends of the spectrum. Most BI applications fall somewhere in between. The tabular modeling experience excels at one end of the spectrum, and the multidimensional experience excels at the other. And if your application lies somewhere in between, you will need to make that trade-off. What works best for you? Okay. Same with business logic. DAX is based on Excel formulas and relational concepts. So the concept of scanning tables, looking up values from another table, relatively straightforward to get started with. On the other hand, DAX does have a learning curve once you get into the more complex solutions. The MDX, on the other hand, requires an upfront learning curve, and the learning curves get steeper as you go ahead. Let me be very clear. MDX is more powerful than DAX. DAX was designed with a goal to make the barrier to entry into building complex BI applications lower. The idea with DAX is to keep simple problems simple, but we're not going to make complex problems any simpler that they can get. I mean, a lot of the BI problems that you have in the BI space tend to get pretty complex, and you will need to understand some of those, the concept of measures, the concept of context, right? When you author a measure, you have to build a calculation that returns the right result regardless of which way the user has sliced and diced the data. That's a concept that doesn't exist in the typical database world. This is something which is a very BI-centric construct. And that's something you just have to get used to. That's why you're BI professionals. But until you get to that point, you can get going. You know, you can a lot of the straightforward BI applications that don't need to get into that level of complexity, You can do a lot of that in a very simple manner. DAX does have calculated columns, which enables a new sort of scenario which doesn't exist in the multidimensional experience. However, we don't have the equivalent of named sets or calc members in DAX. Many of you might consider that as bread and butter for your BI applications, and in that case, MDX really is the right thing for you. Comparing VertiPack and MOLAP, someone asked the question about that. VertiPack is an in-memory column store. MOLAP, on the other hand, is a compressed row store for the most part. MOLAP does a little bit of a column store type implementation for dimensions, but fact tables for which MOLAP was designed for is still a row store. So VertiPack is an in-memory column store. It's the compression algorithms in VertiPack are state-of-the-art. So we typically see a 10x compression. You could see lower levels of compression in VertiPack. Sometimes we even see things like 100x compression. It all depends on, sorry?
300. Yeah,
Ash wants to boast he has a 300x compression.
Yeah, there was the customer called up late last year, from a big company on the West Coast. And they said, hey, I need to check something with you. I'm loading this data from, in this case, Teradata, and I brought it inside Power Pivot. And I'm getting this 300 gigabytes of data I'm loading up, and it's just only taking 1 gig in Power Pivot. Is that expected? I say, hey, this is your data. If you're getting 300x compression, more power to you. So it really does depend. Even though we say an order of magnitude compression, we've seen in real life about 300x compression as well. Fairly substantial.
Yeah, and with MOLAP, we've traditionally seen 3x as the order is the general rule of thumb, without all of the aggregations taken into account. So that's kind of the rule of thumb. So VertiPack, like we've said earlier, we are recommending that you have as much memory on your servers as is required to load the model in memory, because that's really where VertiPack excels. You don't want to have VertiPack starting to page data in and out of disk, because that's not what it was optimized for. MOLAP, on the other hand, is a disk-based storage system, so it definitely scales to models where the model does not fit in memory. That's the only way you've got cubes like the Yahoo cube, which run into tens of terabytes. Obviously, you don't have that much memory on your machine, and so MOLAP does a pretty good job of paging data in and out of disk and back and forth from memory. Okay, and of course, with MOLAP, since it's a disk-based system, you really want to make sure when the system has to touch the disk, it touches as little of the disk as possible, and that's where aggregations and indexes come into the picture. Of course, indexes are something that MOLAP takes care of automatically, but aggregations are something that you, as professionals and IT admins, need to actively manage, and that's something that you don't have with VertiPack. So you clearly see the trade-off there with VertiPack and MOLAP. It's just something a choice that you have to make. Direct query and rollup, we have already seen direct query. Direct query is sort of like the complement to VertiPack. It pushes down DAX calculations down into the back end. Currently, there is no support for MDX query, so direct query is a very early implementation. It's something that we're not going to have time to completely round out in this release, and something that we will broaden out post Denali. But for the basic scenario of doing ad hoc reporting using Crescent over a data mart or a data warehouse, direct query makes a lot of sense. Beyond that, it's somewhat limited in its capabilities for the Denali release. Rollup, I don't need to tell you this. Rollup does a pretty good job for fact tables. It's not really recommended for dimension tables, I know, although it exists in the product today. So how much time do we have?
6 minutes.
6 minutes. I'm not going to go into this. This is just a high-level architectural view of how the BI semantic model flows from Power Pivot to SharePoint to analysis services. This is just basically saying it's the same model. This one model that lives in a workbook, and it flows into SharePoint. You can also have the same model in analysis services published from Visual Studio. You have end-user tools that live on the user's desktop, or you have services such as Excel services and reporting services that can access the model. It's one model. You get it by now, hopefully. Here's the quick summary. It's one model for all end-user tools, spans the entire spectrum of BI applications. Our goal is to provide something that is rich and scalable to meet all of your BI application needs. and still something that gives you enough flexibility to choose what technology works for you. At this point, I'm going to open it up for questions.